Hello, my name is Nishant Rathore, and I'm going to be talking about my course project for Computer Science 6909. For this project, I have implemented a 3D version of a classic arcade game called Breakout. And what is Breakout? Let's start with that. Breakout is a 2D arcade game where players' goal is to break the boxes or bricks that are displayed on the screen with the help of a ball. The ball speed can be controlled with a cylinder bar that is usually located at the bottom of the screen, but the bar is mainly used to prevent the ball going past the y coordinate of the bar. If such event takes place, the player loses the game. For this version, for the 3D version, for my project, I have implemented my project using 3.js and mo.js. mo.js is another library that is built on top of 3.js to handle physics of the elements. And for some physics, I have used collision detection, velocity, applying forces, all that stuff, which is done using mo.js. Now let's look at the interface. So, ladies and gentlemen, this is the project. This is the interface. Now, I just refreshed the page, and you can see that there are so many boxes or bricks, whatever you want to call it, and you can control the ball. You see the ball that is actually breaking all the bricks, and you can control the ball speed using the cylinder bar that is displayed at the bottom. Now you see the ball is actually moving and it just hit one imaginary bounding box. That is the area, or that is a confined space that we gotta work in, and if the ball cannot go outside of that bounding box, so it gotta stay inside the bounding box. So if it touches the edge of the bounding box, then it just rebounds, and which is done using the library mo.js. And my goal is to just control as much as I can, prevent this ball going past this cylinder bar, and so yeah, that's the game. And the speed is actually controlled. There are so different objects have different velocity, and they apply different forces when the collision occurs. So as you can see, that when it collides with the bounding box, its velocity increases, and the reason why it is actually coming down slowly, because the gravity, I have defined gravity at the origin, and this cylinder bar is located well below the origin, which is why that is not very fast going up or down. But as you can see, that this is the game, and all the bricks, the textures and the material on the bricks are generated randomly. User cannot control it. The player cannot control the texture, but all the textures are generated randomly. The materials. So every time you run a new game, you would see new objects would have new textures, and it's all random. And you can also see that I am also moving my mouse, and with that I'm controlling the navigation. So when I scroll down, I am actually moving away from the scene, and when I scroll in, I just see all the boxes, their size increases. I can also go left or right. I can also go up and down. I can also control this navigation using the keyboard keys WASD and QE, and all these keys will just help you navigate the scene. Now you see that here, where is it? Okay, yeah, there you go. So that's the cone that you're seeing. That is actually not just placed there just for fun. That's well, actually, it was fun putting it there, but that represents a light source. So I can move this light source whatever I want. So I'm actually pressing the numpad 2, numpad 8 to change the Z coordinate, and I can also move it up and down, left or right. So this just to tell the user where the light source is located, and I can also turn on and off using the numpad 5 key, and I can change the color of this light as well using the numpad 0 key. So this is one spotlight that is controlled by the user, and there is another one that is the point light source, which is not controllable by the user, but it is there. And this API, this emo.js, this enable 3D API actually comes with one light source as well. So I'm using that one as well, just because it looks all the objects look prettier with that. For the shapes, I'm only using the box shape, just because I just wanted to be consistent. I mean, it was not a big deal if I were to use a different shape. It just in a classic Breakout game, I just wanted to be as canonical as possible, so I'm just using the only one shape. But all the shapes have different mixed textures and materials. For materials, I'm actually using different styles: Phong, Lambert, physical, normal, you name it. There are different kinds, and they all use color randomly, and the ball has its own texture, and the cylinder has its own texture as well. So let's see. If I want to show here is that if I zoom out and I press G, you see that the bar is rotating, and the ball is also rotating around this object, around these objects, and but there's a different rotation going on here as well. The ball is rotating around the bar, and the bar group that is grouped with the ball is rotating around the object. So just to represent the hierarchical relationship between these objects. These two rotations are independent. So if I change the bar position, that it won't affect how the ball is moving. The ball would actually move according to the bar position. So it was really hard to actually come up with an idea to meet the hierarchical component requirement. So this is the best I've come up with, and so the inspiration definitely came from the solar system, how the Earth and other planets rotate around the sun. So that was the inspiration. And it also uses collision detection just to detect which object the ball has hit or collide. So I'm using the collision detection for it, and the API does that quite easy compared to writing your own code from the scratch. And so there's a collision detection there, and the physics. And also, if I praise M for mutate, I see that the objects they have different transformation, and that is done just to make level of difficulty a little bit harder, because if the boxes are changing their shapes, you might miss a box if a ball is around their space. So just to have a different feature implemented, I've done that, and this is not controllable by the user, so the game decides it the way it wants it, just to happen that the first um, row elements got transformed, but this is not mandatory. Any There you go. Oh, any element can be transformed, and just to make it a little harder, I have also once the game finishes and you have the user has hit all the boxes, then what will happen is that you would see um, as as the AI is wishing you, as the AI is congratulating you for winning the game, and when that happens, you will see all the particles just bombarded onto the screen. But since it's going to take much time to actually see that happening right now, but to overcome that, I have also included key event to see that. So if you press P, you see all the particles. They are actually right on the screen. So there are total 1800 particles, and if they are outside of the bounding box area, they get deleted from the memory, and the new one gets created, and that's what you see here. You can press P again just to disable them, and press P again, they're gonna show up again, but they will automatically appear once the game finishes. And it's just because I wanted to keep the gravity at origin, and that's why it's just going a little slow at the moment. But I can definitely change. If I change the gravity to, let's say, higher up on the y-axis or lower y-axis or something like that, then it would be a little bit faster. So that's the game. You can definitely navigate around, and it just looks so beautiful. You see all the textures on the objects, and yeah, so that's the game. That's the interface. And now we're gonna look at the code a little bit. Okay, so there was one Webpack. The library comes with one Webpack builder, and I've used that. But the code, the every line of code that I've written, except the one that came with it, that was just the Hello World project, and everything else is written by me. So nothing much to the code here. Just I'm importing all the modules that I need for my implementation. I'm just declaring one global variable, and I have some class variables declared here, and I'm just initializing all the variables. Let's say the velocity for the sphere, light 1, light 2, this tiles array is to store all the tiles or all the boxes, the group to do the hierarchical transformation, and some helper fields there, and the particle array to store the particles, and in the init function, I'm just preloading all the particle textures, just so that I can use them later on and to save up on performance. And I'm also creating some more, and this is what I'm just creating. I'm just loading the texture, I'm just preloading them, and now I'm loading them, and I'm just applying, for instance, applying those textures. So for instance, for this bar, for the cylinder bar that is used to control the ball movement, I'm actually using this type of texture, and just like that, I'm adding that to my physics. Now, this is the thing with this API, that you gotta do all the 3JS you gotta call all the 3JS methods before you apply the physics, because you cannot do this after. If you do it after, then it won't work. So you have to do it before applying all the physics, and you need this to apply this physics just to set the collision flag, just to keep track of when the collision occurred. And here I'm just defaulting the light positions there, and then I'm adding them to the scene. Here I'm actually so this is the light 2 shape, and I'm rotating it just so that it look like as a cone sending the light out. And this is the API function, and this is actually used to see other things, to control other things. You can let's say if I delete this and if I go back, you see that was one inbuilt light I just removed. So now we have only 2 light sources. If I put it back, then it will be brighter, because the one light source already comes with the API, but you can still control it in the code. And in this nested for loop, I'm actually creating the boxes, and I'm using math.random just to have different textures or materials on the boxes. And let's say if I have 50%, there's 50% chance that the box would get a texture, and another 50% chance that the box would get some kind of a different material. And I'm also calling the capture key event just to keep track of which keystroke has been praised by the user. And here I am creating the particle system. So if the key is pressed, or if there are no tiles left, I'm creating the particle system. We're gonna see that function in a bit. And here I'm checking if the ball has not whether the ball has created. If the ball has not created, then I'm just gonna create one. I'm gonna load the ball texture and just gonna set the velocity, the initial velocity, and the ball will move up or down, whatever. And here I'm actually registering the collision event, and if that event when that fires, just making sure that that this is that happens before the start of the collision. And when that happens, then I'm just updating the velocity. I just want to make sure that if I hit a box, then the ball's velocity should go into the reverse direction, because I've just collided and I want to rebound. So just to see, I'm just changing the XY coordinate of the velocity, and I'm deleting the tile from the tiles array, and I'm destroying the physics of the other object that just got broken. And if it is not one of the boxes, then it's gotta be a bar. And if it is a bar, or if it's not a box, then it's gotta be either a bar or the bounding box. So if that is, then I'm just setting the velocity accordingly. And here, this is just the code just to make sure that the ball doesn't disappear from the view. If it does, then we got a rebound, because we cannot go outside of the bounding box. This animation is done just so that just to transform the tiles when you press the M key. So when you do this, and this is randomly, I'm just transforming each of the boxes. And this is done just to do the hierarchical transformation. And with the first transformation happens with the first transformation happens with ball and the bar, and the second one happens with the bar and the tiles. And here this is the configuration where I'm just loading this class, and this is the particle system code, making sure that I always have 1800 particles at a time at any given time. And then here I'm iterating over the particle count, creating new particles, applying the texture, and making sure that the particles stay within the view. and adding them onto the scene. And here, just to make sure that the particles would have a random movement, so I'm just translating them into the translating each of the particle in the XYZ direction. And here I'm capturing all the key events. So whenever a key is pressed, I'm doing what it's supposed to do. So when a D, A, E, Q keys are pressed, you know that you gotta navigate. You gotta use those keys to navigate around the scene, and that's exactly what it does. Just using the look at function to change the view. And when you're pressing the numpad keys, you're just updating the light movement, position, and the color. And aim for just to do the tile transformation. And these are just the helper functions that update the value of the objects. Okay. Here, get the box and material. This is actually where it creates the texture for the boxes. And this is just an array which is randomly which and the values of these the values of this array is randomly accessed when the boxes are created. So that's pretty much it. So that's my code. I mean, it looks not much, but I had to go from 3.js to fuzzy.js and then to emo.js to implement this. And in the end, I'm quite happy with the way it turned out. And so I hope you like it. Thank you.